Okay, we are going to finish if statements tonight. We are going to look at some advanced concepts. I hope you have had a chance to look at the text and as well as the PowerPoint presentations and watch the videos. This is the time in the course where many students begin to drop out because subject is going to get a lot harder this week, next week, and week after next. What happens is there are so many topics that require a lot of time from students. You need to spend some time and understand certain concepts, think about them, practice them. And if you don't spend enough time, nothing will make sense pretty soon. First of all, you must be very thorough with everything that has happened in the past, in the previous lectures, and you must pay a lot of attention to things. So also there are some common mistakes that initially people make, and I will stress on them. So let's get going. What I would like to do is spend time on things that we haven't, spend more time on things that we haven't done, we didn't do last week. So I'm going to briefly touch upon things we did last week, but then spend a little more time on new things. So let me go ahead and share the PowerPoint here. You have seen these kinds of things even last week. If score is greater than or equal to 90, it is not equals greater than, it is greater than or equals. Print your grade is A. Don't forget the colon here. Then if score is not greater than or equal to 90, that is if the score is A less than 90, control will come here. That is, this will not be executed. This condition will be false. Control will come to this part of the structure, and you are checking if score is greater than or equal to 80. At this point, the very fact that you are here, the control is coming here, means that score is less than 90. So you don't have to check that again. It is a waste of time checking if score is less than 90. So if score is greater than or equal to 80, you can be sure that it is 80 or more and less than 90. So you can confidently say your grade is B. And it continues like that. And if the score is less than 60, we catch that condition using the else and print your grade is F. So think about that fact. Whenever control comes into one of these checks, certain things have been ruled out. For example, when control comes to check if score is greater than or equal to 70, it is because it is not greater than or equal to 70. Because if it were, you would have executed this and control wouldn't come here. So score is less than 70. So if this condition is satisfied, you know that it is between 60 and 60 and more, 60 or more, but less than 70. And you can nest if statements. You could write like this: if total cholesterol is more than 2000, you have to write the corresponding Python statement, of course. If systolic BP is more than 135, that is, you check this line, this condition, only if this condition is true. Print something like you need treatment. So this is pseudocode, of course, but it translates very easily to Python code. So you will print you need treatment only if this condition is true as well as this condition is true. Otherwise, of course, Python will have else in place of otherwise. Print watch your cholesterol. Why is it watch your cholesterol? Because it is this BP more than 135 is not true. This otherwise goes with this if, or the else goes with the most recent unmatched if. This otherwise goes with this if, because that is the most recent unmatched if. This if has already been matched. And so it goes. So this is the Python version of it. An easy translation once you get the logic right. Now, let's look at new stuff. Suppose you want to have a rule in a city or someplace where you tax people, and you say that tax rate is 15% if income is 30,000 or more, but less than 50,000. So you can write it like this. If income is greater than or equal to 30,000, if income is less than 50,000, set tax rate to 15. That is, you check if income is greater than or equal to 30,000 first. And if that is true, you check if income is less than 50,000. And if that is also true, set tax rate to 15. This can be quite messy to write after a while. So what you can do is you can combine the decision. You can write if income is greater than or equal to 30,000, and then you write and. This is what you type in Python, AND, the word and. Income is less than 50,000. That is, if this condition is true, and this condition is also true, then the whole thing is true. First of all, check. Again, note this. If income is greater than or equal to 30,000. So if somebody has an income of 35,000, that would be true. Then you check. If that is true, you check if income is less than 50,000. With 35,000 as income is less than 50,000. So the second part is also true. If both are true, the AND connects them and then says the whole thing is true. So this whole condition is now true. Okay. And because the whole condition is true, we set tax rate to 15. On the other hand, let's assume income is 15,000, 15,000 or 20,000, one of those numbers. Then if income is greater than or equal to 30,000, with an income of 15,000 or 20,000, this will not be true. So Python even doesn't bother checking the second part, and the whole thing is false. If any one of these conditions is false, the whole condition becomes false. So tax rate will not be set to 15. On the other hand, let's assume income is 60,000. If income is greater than or equal to 30,000, income is 60,000. So it is definitely greater than or equal to 30,000. So this part is true. So Python goes and checks the second part. Income is less than 50,000. The answer is false. So true and false gives you the false logical value. The whole thing is false, and Python will ignore this line. Set tax to 15. Questions? Okay. Let's look at another way of combining conditions or decisions. If temperature is less than -10, let's assume that we want to print an alert. We want to send an alert to every cell phone, or you want to have a siren go off or something. We also want to do that if the temperature is more than 110. which is quite possible in the coming years if things go the way they have been going, right? So this can happen almost every winter here in Minnesota. So, and this could possibly happen in a future year in the summer. So we want to have a program that would send out an alert on the TV or on a cell phone or on a siren, whatever. If either one of these things happens, we want to print an alert. So if temperature is less than -10, print alert. If temperature is more than 110, print alert. Instead of doing it repeatedly like this, we can combine them and write, if temperature is less than -10, or you type OR, the word OR in Python. Temperature is more than 110, print alert. So if either condition is true, for example, if the temperature is, let's say, -20, then it is less than -10, Python will not even bother to check the second condition. It will print the alert. If the temperature is, let's say, 120, heavens forbid, then the first condition is not true, but the second condition is true, and we will print alert. If the temperature is, let's say, 90 degrees, it is more than, it is not less than -10. So this condition is false. So Python will check the second condition. Is there a possibility that it has to print alert because temperature is more than 110? The answer is no. Temperature is 90 degrees, so it is not more than 110. It will ignore the print statement. That is the OR. And there is something called a Boolean variable. Let's talk about this using a different share. Let me use the whiteboard. What is a Boolean variable? See, we have been using things like number or counter equals 5. We have had things like price equals 8.2 or name equals Mary, right? We set a variable called counter to 5. We could do that. We could set a variable price to 8.2. We could have a variable called name, and we could set it to Mary. This is a number, of course, and it has no decimal point. This we know is an int. We need integers. We would like to distinguish them from things that have fractions quite often. For example, if you're counting, you don't want to say fractional number. We don't have fractional numbers there. It is not appropriate. It confuses people. Price equals 8.2. Well, if you have price, you better have decimal points and fractional parts. You can't use integers. This we know is float. And when you have names of people, you need strings, right? You can't have numbers there. So there is motivation for each one of these different types. Now we introduce a new type called Boolean. The interesting thing about a Boolean is that there are only two possible values. If you have a variable that has a Boolean value, it can only take one of two different values. If you think about a counter or a price or a name, they can take a large number of, possibly infinite number of values, right? Numbers never end. You can have strings of various lengths, so names can also be infinite. But a Boolean variable is interesting in the sense that there are only two possible values, either true or false. So result equals, you can write true, or you could write result equals false, or debugged equals true. You can write like this. So true with a capital T for a change. Here, for some reason, which I don't understand, Python uses capital T for this value. This is a value, this is a constant, this is a literal, it's a Boolean literal. False also is having capital F. Don't put lowercase f, it is not correct in Python. In other languages, you will find lowercase f and lowercase t, but not in Python. So what is the use of this? The use of a Boolean variable is to remember decisions. As you write your code, you have you test values of variables, you add, subtract, and then check whether the value is more than something, etc., etc. And then you want to remember some of these decisions. At that point, these Boolean variables are very useful. So for example, here, going back to the slides, suppose you need to check a set of complicated decisions to decide whether an employee qualifies for benefits. Okay, so if income is less than 30,000 and status is equal to disabled, insurance premium is equal to 0. Otherwise, insurance premium is something. If income is less than 30,000, status is disabled, send notification to social services. So you have the same condition, income less than 30,000 and status equals disabled. You have that over here. You have the same condition over here. So instead of checking these things over and over again and again, you could simply use a Boolean variable. If income is less than 30,000 and status is equal to disabled, you set a Boolean variable qualifies for benefits to true. Otherwise, you set that variable to false. So you're remembering what happened, what the status is in this variable, which is a Boolean variable. Later on, you can check if qualifies for benefits is true. That is, you should actually check equals equals, not is. In Python, that is the right way. Okay, but this is pseudocode. So you would write this as if qualifies for benefits equals true. You will have some code that sends notification to social services. Or you can write if qualified for benefits equals true, insurance premium equals 0, else insurance premium equals some formula. There is another Boolean operator called not. Not is very different from and or. We have looked at and, we have looked at or. Not operates on a single Boolean variable. If you have a Boolean value, not of that flips it. So it's like, if it is true, it changes it to false. If it is false, it changes it to true. So not Boolean variable equals true is the same as Boolean value equals false. So sometimes it is very useful to use not operator. For example, read average score into the average of a test into this variable average score. Read the maximum score, who got the maximum, but that value, that maximum score, maybe 95, whatever, is into maximum score. So you have two things. This is an example of using not operator. The average of the test and the maximum value that anybody scored. If average score is greater than 80 and maximum score is greater than 95, we set a variable called EC test to true. Otherwise, we set EC test to false. So this is our criterion. If the average in the class is more than 80 and the maximum score is more than 95, we arbitrarily decide that is an EC test. Okay. Then later on, suppose you read somebody's score, okay, and let's say that score is some score, some arbitrary student, that score is some score. If some score is greater than 90 and not EC test, that is, if it was not an EC test, if EC test is true, this will be false. If EC test is false, the whole thing will be true. So not looks at a Boolean variable, a Boolean value, and flips it. If EC test contains the value true, this expression will become false. On the other hand, if EC test is false, the whole thing will become true. So based on that, you are saying you did well. That is, if you scored more than 90, and if it was not an EC test, you print a congratulatory message. And we, if you think about it, we in real life also talk in terms of, I mean, we use not in many contexts. So you might find a lot of opportunities for using this. Okay. Sometimes it is easier to apply a not rather than check for a complicated condition. Now, I want to spend some time on a couple of more things. So let me let me see if I can copy this. Maybe not, I'm not able to. Okay. Let me go ahead and stop sharing and share the whiteboard. If you, I'm going to write some arbitrary statements. If you write if A minus B is less than C plus D, how is this evaluated? I don't have any parentheses. The question is similar to writing things like this: 2 plus 3 times 4. I don't have any parentheses here. What gets done first? The answer is multiplication. That gets done before addition. So this will be 3 times 4, which is 12, and that is added to 2. So the answer is 14. It is not 2 plus 3 times 4. It is, the answer is not 20. 2 plus 3 is 5. 5 times 4 is 20. But the answer is not that. It is 14 because 3 times 4 is done first. Similarly here, what gets done first? Does it do the comparison first? The answer is no. It does the arithmetic first. So A minus B is done first by Python, and then C plus D is computed, and the two values that are computed, that is from A minus B and C plus D, they are compared. It is not like B is compared against C. You should know these rules. Otherwise, you will start writing like this, which simply adds more tokens into your expression. It sometimes makes it harder to understand. It depends on people, but I think you should try your best not to put in too many parentheses. Otherwise, you'll see lots of parentheses and it gets very difficult to understand things. So arithmetic is done first. Then comparison. Okay, but we have another problem here. We have also and, or, and not. These are logical operations. So here, arithmetic will be done first, then all the comparisons will be performed, then we will perform logic. So A, C, and then L. It is in, I sometimes think of it in the alphabetical order. Arithmetic, A is coming first, right? Then C, comparison. L comes much later, which is logic, right? So I think of it like A, C, L. So let's look at an example in the lecture PowerPoint. Okay, here. If you have something like this, B less than A plus 3 and all that, what gets, I mean, I have parentheses, obviously, but here I have written the same thing without parentheses. What happens first? Well, if you look at this, all the arithmetic will be done first. So A plus 3 is done first. Then it looks for more arithmetic. Here is more, A plus B. So this A plus 3 is done first because it is the first arithmetic operator. Then this is the only other arithmetic operator, though, so that is done second. Once the arithmetic is done, it goes and does the comparison. So B will be compared against the sum of A and 3. Then B will be compared against 4. And the sum of A and B will be compared against 5. So we have a value here, B less than A plus 3. Can somebody say what the type of that value is? When you compare B and A plus 3, writing B less than A plus 3, what is the type of the result? Is it a number? Is it a string? Or is it something else?
It'll be a Boolean true.
Very good, fantastic, thank you. B less than A plus 3, either that is true or that is false. That depends on B and A, right? So this is either true or false. So that true or false is taken, but then here is an and. So, but, or rather, I should say there is a not here. So nots are done before ands. Logical operators are done after all comparisons are done, but then nots will be done before and. So what it does is it does a not on something. What does it do a not on? Not operates on?
B is equal to 4.
Exactly, great. It looks at the result of B is equal to 4. Is it true or false? If it is true, not will make it false. If it is false, not will make it true. So that is done. Then it will do all the ands. So how does it do the and? It will take this logical value and the value that we get out of this and then does an and on it. If both of them are true, the whole thing will be true. Otherwise, the whole thing will be false. And finally, or will be done on the result of this and the result of all of this. So if you were to write this using parentheses, it will be like this, which is not what I like. Okay, that's all. I'm not going to take off any points if you write it this way, but there is a school of thought that says you should not use too many parentheses. It becomes very difficult to match them and see what is going on. These may be a little easier to read. And you should spend a lot of time on these, work out the details, and do as many problems as you can. If you don't, you will be in serious difficulties in this course and any future courses that you take. It may not be very pleasant, but you have to take the pains to understand these things. I cannot overemphasize these things, right? Finally, last but not least, as they say, please pay attention here. Every year I show this, in every class I show this. Then the lab comes along and people simply don't follow these caveats, these warnings. So everybody, please pay attention here. Look at these things. Don't make mistakes. Okay. You don't write like this. If A is 10, that works in Python to some extent, but you might have unpleasant surprises and your program might have bugs later. Instead, write if A equals 10. Okay. If A is 10 if you write that way, your code may work sometimes and sometimes it won't work, because the meaning of that is somewhat different from checking whether A contains the value 10. Please don't write this. Don't write like this. If 10 less than A less than 20, that is A between 10 and 20. It might work in Python. I don't know. I don't care. I can't care less about that. Very, very few languages support something like this. If you get into this kind of habit, you will find it very difficult to, you're just practicing bad habits then. Okay. And it becomes more difficult to learn other things. Instead, write if 10 is less than A and A is less than 20. To check if A is between 10 and 20, write if 10 is less than A. That is A greater than or equal to 10? And then check A is less than 20, like this, This is plain wrong, the next one. If you want to check if A is either 10 or 20, you could probably say this in English, but Python will not work. In Python, it will not work. In some languages, it will flag this as an error. It seldom works in programming. If you want to check if A is 10 or 20, you must write it like this. If A equals 10 or A equals 20. And tonight we have a lab. I'm expecting at least half a dozen people to write like this. And the code will not work. Okay, so please note this. Don't write like this. If you want to check if a value is equal to 10 or 20, you must write if A equals 10 or A equals 20. This is the correct way. This is a frequent problem. In fact, all of them are frequent, but a couple of these are even much worse, because Python will not flag an error for this if A equals 10 or 20, and it simply won't work. It will always be true. And you'll see that your program sometimes works, sometimes it doesn't work, and you have a buggy program. It will be very hard to debug such things. Instead, write like this. Of course, this will be, this I have seen some people write last week. I had seen that, but it is much easier to overcome quickly. Don't write if A equals 5. Equals is for assignment. If you want to compare for equality, you have to use two equal symbols. I'm less worried about this than this and this. This is another huge problem. If this makes no sense to write what is on the left hand side. If A is not equal to 5 or A is not equal to 6, what does it mean? Probably nothing. It's just plain nonsense. Okay. What are you trying to check? I don't know, really. If you are checking to see if A is all values other than 5 or 6, right? That is, you are fine with negative infinity all the way through 0, 1, 2, 3, 4, 7, 8, 9, 10, 11, etc., up to plus infinity, but you don't like 5 or 6. Then the correct way to write is if A is not equal to 5 and A is not equal to 6. This is always a wrong thing. Python will have no problem executing this, but you will not get the right result. So please, for your own sake, to avoid frustration, you must pay attention to this table. Okay. I hope all of you note these things and do not repeat these mistakes. These are so common, and why do you want to waste your time? Spend 5 minutes looking at these and avoid these mistakes rather than waste an hour trying to figure out what went wrong. Okay, it is for saving time that I'm saying, saving frustration. Don't write if A is not equal to 5 or A is not equal to 6. Suppose you have, basically what you are saying is, I don't like 5 or 6. I don't like either of those two values. Suppose A is equal to 5. Okay. Then what is this? A is not equal to 5. Is that true or false? A equals 5. A equals 5. So this is true or false?
False.
False.
False. A is 5. 5 not equal to 5. I mean, 5 is always equal to 5. So this is false. Fine. A is 5. 5 not equal to 6.
True.
True. So this is true. So with A equal to 5, the whole thing is true. Suppose A is equal to 6. What about this?
It's false.
A is equal to 6.
That's false.
6 not equal to 5 is?
To be true because 5 is not
Oh, yeah.
equal to 6.
6 is not equal to 5 is always true. So the whole thing is true, right? Because you don't even have to check this. Okay, so with A equal to 5, this is true. With A equal to 6, this is true. Suppose A is not 5, A is not 6. Suppose A is something else like 4. 4 not equal to 5? True or false?
True.
So the whole thing is true. So what we are saying is that this is true all the time. Right? So that is the fallacy of this. This makes this condition always true. Similarly, this is also always true because of the way Python does things. This A equals 10 or 20 is also always true. So they are plain wrong. So please pay attention to this table as you are doing your lab tonight. I have seen at least half a dozen students make these mistakes in the lab that we do this week. Please, for your own sake, I mean, get these things, pay attention to this and refer to this table as you are coding your solution for the lab. Okay. Any questions before we do the class exercise? All right, let me stop recording.